Great. So, hi everybody. I'm very excited to kick this off. So, we've all looked at the stars. And although the view of the stars from Boston is not really the best, you can kind of get a couple. You can imagine what the sky would actually look like if you turned off the lights of the city. And you'll be able to see this majestic galaxy, or at least the tails of it, all the way up right there, which is quite incredible. That's something that you can do when you drive a little bit outside the city. So first, what I would like to do is to really place where we are in the universe, and in particular, in the part of the universe that I do study. So starts with the Earth. I'm from Tunisia. It is in North Africa right here, under the clouds, which is so unrealistic, because when it's cloudy, my mother would call me in to tell me that, oh my God, it's cloudy today. Sad but true. So keep your eye on the Earth. As we move out, the first thing that we're going to see is our favorite and closest star. That's the sun, located 8 light minutes away. But it's not really the center of anything, because as we move out, we can see that we are part of this large galaxy called the Milky Way, and we live right here at the edge, with for example, two of many smaller galaxies that are currently falling into us. And if you think that this is beautiful and majestic, which it is, I can tell you that what I'm interested in is what lies even beyond this. And in particular, it's this dark matter halo. So our small galaxy is living in this big, big chunk of dark matter, something that we don't know. It's probably better to call it invisible matter. And just to kind of give you some numbers, it extends about an order of magnitude in distance further than what we do. So remember, we live at the edge of this galaxy, and we're just surrounded by something that we just don't understand. You might wonder, okay, how much of that is there? Well, if you think of all the matter, electrons, protons, and all the things that we're made of, that the stars are made of, that gas is made of, my laptop, my phone, all of it, it only makes out a very small 15% of the entire matter in the universe. The rest of it, the rest of the matter, not the total energy budget, but the rest of the matter of the universe is this invisible dark thing that we really don't really know what it is, but we know that it acts on the things that we use. So how do we know that such invisible thing that we don't really see is there? Well, there are lots of lines of evidence, but one of my favorite is rotation curves. So if some of you did undergrad here and were in my 8-to-1-2 class, you would have learned about how the velocity changes as a function of distance. So just for refresher, the sun, not to scale, is about here. So we live at the edge. And from 801 or 801.2 knowledge, you would expect that the stars at the edge of the galaxy, like ours, would rotate much, much slower than the ones in the middle. In the 1970s, with the work of Vera Rubin and collaborators, she found out that we actually live in a galaxy that looks a lot more like this, where the stars at the edge, just like the sun, are rotating almost as fast as the ones in the center. And what keeps all of this together is this invisible large dark matter that we really need to understand because it makes up so much of the universe. So although we get to enjoy views like this, where we put our telescopes in Chile in the southern hemisphere, because the southern hemisphere gets us to see the center of our galaxy right here. Unfortunately, we can't see that from Boston. And it gets us to see those satellite galaxies, the ones that I was just talking about. This is the Large Magellanic Cloud, LMC, and this is the SMC. What I'm interested in is not just this, but really what lies underneath and what is the dark matter. So if I had dark matter goggles, I would see something that looks a little bit more like this, where there is this invisible thing that is surrounding the largest of these galaxies. So it's going to be around the center of my galaxy. It's going to be around the center of the satellite galaxies. And there will be smaller things all around. The thing is, we don't really understand yet what the particle nature of dark matter is, which means that although this is the most common picture of dark matter, it might actually look like this, where you don't see those small blobs anywhere. Or it might be self-interacting, where the shape is a lot more spherical and the density is a lot more uniform. Or it could be something else altogether. And what I want to do is really use the stars to figure out what's underneath. So the goal of my research program has been to map out the stars to get to this invisible thing underneath, which is dark matter. To do such a thing, you need me to have 3 components that I'd like to kind of think about: telescopes, machine learning, and some amazing scientists. So let's go through these. Telescopes. I do use a lot of telescope data, but I'm going to tell you about my favorite telescope. It's called Gaia. Gaia is a European space mission. So it was launched in December 2013 and has scanned the sky to give us the motion of 1.5 billion stars. It's a big number, even for us. It's a really big number. And to just put this in perspective, this is the extent of what Gaia would see, that big circle right there. The tiny circle where it says sun is not really just to show you where the sun is, but that's the extent of the previous mission called Hipparchus, which gave us access to 100,000 stars. So we went from 100,000 to 1.5 billion, such that we can make videos like this when we can pick 90 million, a small subsample, and run their motion for the next 800,000 years and see how they're going to move. And that motion tells us about this underlying gravitational field that is dark matter. So Gaia is a previous mission, but there's things to look ahead for. And one of the things I'm very excited about is Roman telescope, which is expected to launch next year, fingers crossed. And it's particularly because it was named after Nancy Grace Roman, who was the first chief scientist at NASA in the 1960s. Moving on from that, I'm going to tell you a little bit more about machine learning. As you can imagine, if you have to sift through 1.5 billion stars, doing that, or having a poor grad student do that, that's just not going to work. You need to adapt, and you need new methods. And as a senior investigator of IFI, which is an NSF Institute of Artificial Intelligence and Fundamental Interactions, it's a bit of a mouthful, but basically, we get to collaborate as physicists or scientists with AI scientists as well, here and in neighboring universities, to really come up with new machine learning ways and machine learning techniques that are very much adapted to our science questions. We can't really use things that have industry right away. So there are lots of cool things that we can get out of machine learning in my field of study, so I'm going to just focus on one of them. And the cool thing about astronomy is that if you find something, you get to name it. So let me introduce you to my favorite thing, Nix, which I named after the Greek goddess of the night. This is 100 stars, a collection of stars that are going right through us, so very close to where the sun is. And the reason that this is interesting is because they have an interesting motion. So they kind of rotate just like how the sun would, which is why we haven't seen it before. But they have like this extra kind of tilt that they're going into the center of the galaxy. And the reason that this is interesting is because it can come from a couple different ways. Is it because something smashed into our galaxy and these are ripples, just like you would in the water? Or is it that these stars are actually remnants from a merger, from another galaxy that came into ours, and this is what's left over? So really trying to understand the history of the Milky Way starts here. Moving on from machine learning, I think we can go into the most critical part, which is the scientists. The Milky Way is big, and my research program kind of goes through multiple different areas of it, and I would not be able to do all the cool things that I can do if it wasn't for the amazing team that I get to have here at MIT. So we also had like a whole thing about finding a name for ourselves, so we call ourselves the Cosmic Code Breakers, and my students actually also made the logo for us. We have merch. But these amazing and brilliant people are really what keeps pushing this whole research endeavor. So when we actually look at the stars and try to find how most of the universe is kind of missing, or the 85% of the matter budget in the universe, you might wonder, why should I care? I mean, it's invisible and okay, fine, it's a lot of it, but yeah, how is that gonna affect me? Well, I would assert, and similar to what the dean was just saying, is that basic science is a critical investment to empower humanity. And usually the examples that I tell people who ask me about what I do are Maxwell, when Maxwell put the equations of electromagnetism and figured out how light kind of propagates. I don't think he was thinking about radar, which is really built on Maxwell's equation. And I don't think he was thinking, oh, this is how they're going to know that it didn't rain today, or this is how they're going to be able to land their airplanes. Similarly, when Albert Einstein built GR, or general relativity, he was trying to figure out, oh, what's going on with the orbit of Mercury, but didn't realize that we're going to use such a thing to build GPS, which is how we got, well, through the maze that is the MIT campus to get into this building. So dark matter is going to be a brilliant discovery. Whatever it is, whoever does it, it's going to be amazing. And yes, it might be decades to come, but I'm sure that there are these amazing people who are going to try to figure out what to do with that knowledge. So I'm going to tell you today and leave you with this, that yes, we're going to be looking at the stars, and I hope that as you go outside today or later tonight, you're going to be looking up and imagining all this invisible stuff that is all around us, which hopefully one day we won't have to imagine, because we will know what it actually is. So thank you so much for all that you do to make this possible. Thanks.
Thank you, Professor Necib.